compute capabilities on a single board computer. Here, in this case, it's a Raspberry Pi. And the reason it's kind of cool is that webOS is an embedded Linux distribution, and it's so much smaller than something like Ubuntu. And you can really sort of build from the ground up only the components that you would need. And so it avoids all the overhead and inefficiencies that you might have.
Are you building, are you running on the 64-bit kernel or 32?
No, it's not. We need access to camera, we need access to display. I think that's not available in 64-bit Raspberry. Yeah, this is issue with Raspberry, not really with webOS.
I sunk an entire afternoon on Sunday trying to get Ubuntu 64-bit on the Raspberry Pi, so then I wouldn't have to compile
you can't do that.
ROS 2, and I could just use our ARM's V8 binaries, but it turned out to be faster to just use Raspberry and then compile ROS 2 on CH.
I think we had that issue where we were actually originally just looking for the ROS 2 ARM binaries, and it turned out it was only 64 bits, and so then we just like...
I made a Docker container.
We also made a Docker container to build in with QM inside the Docker.
This is so easy.
Everybody's doing that.
Yeah, I could configure CMake to do the cross compiler, but who has time for that?
I spent like half a day and like just Docker.
I'll settle for maybe 2 times as long.
So 64-bit build. I mean, technically it's supported by webOS, but I mean Raspberry Pi doesn't support it. Like it's not fully open source client libraries. That's why we are not using 64-bit.
Are you talking about the kernel binary, the kernel blobs?
Yeah, it's the Broadcom stuff.
Yeah, that was the other thing I had an issue.
I think currently at this point, I think only Camaries has an issue on display. Like 3D accelerations, they have solved it. It's open source from Mesa, but there are still a couple of things missing, and we kind of fully do it here. But if you are using different hardware where you have all the drivers or all like available from vendor, webOS should be able to build there.
How would I get webOS? You guys have ISO images?
So webOS it's not like Ubuntu. You don't get ISO image and install it. It's other way around. It's more developer oriented. So on Ubuntu, what you do, you install ISO, then you install this package, upgrade this, upgrade that. You install pip, right, and it's a nightmare to maintain. In webOS, it's other way around. It's based on open embedded like distribution. Open embedded like builds everything from source.
Yeah, that's right.
So you typically select packages you want to have, and then you say build. It will figure out all the recursively dependencies and build you an image which you flash to your device, and that's it. You don't install anymore. You configure it at a build time.
Alright, well, what were you using Docker for? You were using Docker to...
No, we don't use Docker for it.
No, I know.
We use Docker to build 32-bit binaries for Debian, for Ubuntu, sorry.
Okay.
That's a separate thing. Okay. This is just building on your. This is cross-compiling on your host system for target architecture.
Okay.
Automatically, the open embedded maintainers maintain this build system.
So you have the entire thing working.
Yeah. Like technically, you can build for 64-bit without issues, but you'll need to provide drivers, otherwise something won't work. If you don't need camera interface, you can use USB camera or something. Then it will be fine. It will work on 64-bit kernel.
Maybe you should also explain about web applications.
Yeah, so web applications, that's the main, that's why webOS.
Yeah.
So webOS is operating system where the applications, the user space, I mean the UI is written in web technologies, HTML, CSS, JavaScript. We provide optimized like Chromium build. It's not like regular Chromium, it's more optimized for these kind of devices because LG TVs use similar chips, like very small, not a lot of memory, so we can spend a lot of time optimizing this UI. And what we did, we integrated this with ROS. We put the ROS web bridge, so your web applications can talk to ROS and provide control messages or some UI elements. Like in this case, it gets a camera image and shows something.
So leveraging the web ecosystem is certainly advantageous to like accelerate development. But like JavaScript, like the memory intensive.
It depends what you do, of course. That's up to you to decide what kind of application are you creating.
Well, you can see that we made the application with a lot of animations.
I mean, I would expect you don't need complex web UI. You're not making Facebook here. You are typically showing some UI elements, maybe eyes, maybe some control mechanism.
Menu.
It'll make it a lot easier to make UI.
Yeah, exactly.
Yeah, exactly. You just make it in the browser, like HTML page, and then you offload it to the robot. and you can easily verify that it works. It can also connect to the ROS and receive the messages from the same your web page. So if you have a robot which you want to run on a cheap small hardware where you have a display and you want to have a menu or something shown there, and you need to have integration with ROS, you want to receive the information from the wheels, from from sensors. That's the easiest way.
I'm trying to think back to your ROS contact. Were there any major difficulties in incorporating ROS 2?
Oh yeah, we had a lot of difficulties with performance, mostly because the ROS 2 before us, I think not so many people actually run the ROS 2 on the Raspberry Pi, especially the Python bindings. C++ was okay, but Python bindings was a nightmare.
For performance point of view.
What was the numbers like?
It had
7
memory
seconds.
leaks. It had a lot of memory leaks. It had performance issues. When we first ran it here, it had like a line following algorithm. You press a button, it follows the lane. I think there was like a 5-10 second delay until like a control command comes back for this specific frame. It was like impossible to drive.
So like 5 to 10 seconds.
We got it down to like less than half a second or something.
Python's just really slow.
No, it was not a Python
not
issue.
about
It was just a ROS2 bindings that were written in a weird way. A lot of asserts, a lot of like
So they
debug
were
information that you
checking
don't really need.
if you send image, then it was like the array of the integers, and then every integer is
Oh,
a
it's a byte objects. Each byte object is like one length of list like element.
Oh.
And,
So
and
it's
for
check-
each element, it does like a bunch of assets. Assert is it a list? Assert is the length one. Assert is the value inside from 0 to 255. These kind of things.
Yeah, so there were like performance issues. I mean, the other aspect was that as far as like porting it to ROS 2, that part is sort of much easier.
Yeah.
Basically, you just have to, any existing Python packages, you just have to move to Python 2. And then it's just a matter of like making sure that everything builds before you actually deploy it on this robot, since basically you're flashing the entire image and it will work out of the box. After that, then you start looking at like pulling up the services to just automatically load everything.
How do you develop using that kind of capability?
So
You
there are-
flash and then you run and
So
then
there
you
are
remote
multiple things.
GDB debugger. Or
You
how
can also- yeah, you
I
can do
compile
that.
on the platform. I can't compile. None of my development dependencies are in platform.
So there are two things. One thing is you can develop an emulator. Instead of building for target device, you can build for QM emulator. Then you get basically same UI on your desktop as in a QM window.
But we didn't actually do that.
Yeah, we didn't do that. That webOS build supports that.
Yeah.
Then you can do like a demo GDB with Qt Creator if you want to really step
But,
through it.
like,
That's
as
easy.
I said,
I mean-
I'm iterating on one particular process.
yeah.
I have to agree
No,
with
right,
all
right.
No,
this.
this is
So
just
what you do,
one
you
thing.
build an image,
Yeah.
you put image there, you make sure that it is read write, and then you just rebuild your package which you work on.
Yeah.
And then you copy file and
Just
restart
copy
there.
the binary.
Yeah, or
Yeah.
just copy the binary. So
In the case of
And-
Python, it's slightly easier because you can just
Edit Python.
edit the Python files directly.
Just an interpreter.
But there is third option, NFS root.
yeah, and
You can
that's-
build the image and so that it will have rootfs on your desktop, and then it will boot from NFS from your desktop. And then you have all the files locally in your file system, which you can easily replace, change it. And then it's just a question of rebooting if something hangs.
webOS should have a lot of documentation, and LG wants to make it open source and
You can
wants
see
to-
what it supports, like all these cool technologies.
So LG like revived webOS. Is it the same webOS from like HP touchpad?
Exactly. Yes. Yes. So that was the webOS.
How do you know about webOS?
Nobody knows.
No, that's cool. That's cool.
Yeah.
You're really
I-
following up trends.
I worked at Texas Instruments and all of my embedded friends were like, oh man, check out this new one for Instruments. We got the touchpad, we're trying to we put Android on it.
Yeah.
And then
So
we're sad there's no more. Now it's good.
yeah. So the Palm made webOS. Then it was acquired by HP because they couldn't make a device. Then HP was sold this to LG and LG was able successfully make the product, and that was TV. And actually, that's the best-selling TV. If you look at the webOS, like smart TVs in US, they're one of the best-selling.
All right, so now.
And now LG says, okay, we put it on the TV, but we don't really find any other ecosystem where we can bring this technology for mobile. It's a little bit too late for other devices. Not really clear what should it be. So this is why they open source it, and they said, okay, now like use it, play with it. And one of the ideas how to how to bring it to developers was to make it easier to make robots with webOS.
From a user space, how is webOS like different than like embedded Debian kind of things? Like,
So for system services, it's pretty much the same. It's like, you can interact with dbus, you can interact with Command.
so like if I need to configure Wi-Fi or...
So that's provided by webOS services. They have like their own IPC called Luna. So you can say like Wi-Fi up and like Wi-Fi scan and stuff like that. It's custom. It's made so it's really easy. You don't need to really configure low-level despotic files. It's just like a...
There is a settings application. If you just take the stock image, there is a settings application. It already gives you the view. You just click settings button and shows
but from application point of view, that's just RPC API.
from application point of view, all the system things like Wi-Fi settings, multimedia, volume, and they have a...
Which kernel is it shipping in?
Sure.
Do you need a version?
We can get the version.
3.6 something.
So
maybe?
it's really not a webOS property, the kernel version. It's open embedded property. Whatever version you choose, you can build it. If you want to upgrade yourself, it's just a question of changing one number and build it. That's it.
In that ecosystem, do I look for webOS support for a certain target, or do I get like a certain base image of a target and then apply webOS?
So OSE edition, which is open source edition, officially targets only Raspberry Pi. But we know it can run on different chips.
It should be the same as open embedded. Basically.
Well, yeah,
it should be possible.
it's not really like a base image. Like,
it's not an image. It is. It is basically the configuration. You can basically like think about it as open embedded, which is a puzzle by itself with a lot of components and the configuration, and we just solve the puzzle. So you don't need to choose what kind of the kernel you want, what kind of clip XML you want, what kind of clip SSL you want, what kind of the multimedia libraries. It already includes the multimedia support with all the codecs, which
but we're like it's
with
like,
compositor.
is there like some kind of modularity? Like, is there an open embedded implementation for Rust 2 already just imported to get Rust to function? Do you have to do like that yourself?
so
For ROS 1, there is from
Yes.
the BMW, I think. They maintain for ROS 1.
BMW, Intel. Yeah. So there is like an
For open embedded.
There's an active open embedded layer which contains the ROS components. These are like the recipes that build those specific ROS packages. There's still a lot of work to be done. For ROS 2, it didn't exist at all. So all of the packages that we ported from ROS 1 to ROS 2, we made the entire layer ourselves.
Actually, we forked the repository and added those.
Yeah. So then what you have is like all these different layers that are amalgamated into this OS image. One of the parts of that is open embedded and the normal things that is in
they
other
have
things.
the core layer with like really basic packages like shell, the kernel, other things. Then they have a services layer. Then they have a UI level with multimedia, and all it does, it just chooses the packages, like which version, where to download, and like how to build. Some of the packages might have patches if you want to do some adaptation, and like bug fixes. Well, basically that's it, right?
So if I'm going to use this for like my IoT device, what's my avenue for like over-the-air updates and stuff like that? Is there an instruction for something like that?
So by default, Open Embedded builds like whole image. You change one tiny thing, new image. But they support like Delta updates. You need to make them like enable somehow. But if you have previous like image and you generate new image, it can produce Delta update. Then it's up to you to have like some kind of service which can download this Delta and apply it to your existing.
I need my own prawn infrastructure to like.
To deploy, yes. But to build it, Open Embedded will do that for you.
My understanding is that LG for the webOS, which is deployed to the TVs, they solve the problem. They have a service, they have a system like do those updates. But I think these are not open source. We need to check is it open source or not. But I got some feeling that it is not open source. So the open source like the basic framework up to the web applications. So if you want to make a really nice UI with menus, flying buttons, some effects, like yeah, that's just really.
Anything special interacting with Intel?
Yes, we had a lot of hard time before the good times.
Yeah.
So the hard time was mostly about their SDK version 1 had issues with the model conversion because how you work, you do your model, you basically make the model architecture, you do the training in TensorFlow or in Cafe, and then you save this model, you convert it to their internal format which they understand, and then every time you want to do something, you say open device, load the model, and this is the input, give me the output. And if the model includes layers from TensorFlow, because with the TensorFlow you're not really sure. I mean, you need to know what exactly it actually generates. We use the model which generated some layers. Like the kinds of layers which are not supported by this thing, and we spent like 3 days finding out what's actually wrong because it gives you the random results. So here the output of the model is like 1,000 element float vector, where each element is the probability for the object. So it supports like 1,000 kinds of objects, and it was giving us this random values. And there's like you put it says this is chair. You put it again, it says this is I don't know the cup, and that was very unclear what's actually wrong. But after we understood that we need to use Cafe, and we have to be really careful with the dimensions of the input. It works really nice. It actually works really fast. I think it's 20-24 frames per second. So yeah, we don't do this because we don't need it. But if you need, you can really.
Do you downsample the image? Like what's the resolution you get?
I can't say you for sure. I think we do because it's HD, but I can't.
Actually,
if we do, we don't do that much. So yeah, the cool thing is that
we did it for the lane following.
How much power is it drawing? You have 500 milliamp cap to USB 2, but what do you think is actually drawing?
I don't actually know about that part. Someone asked us earlier.
Yeah, we were counting how much we can spend, and
I think it's isn't it USB 3?
Raspberry Pi doesn't have USB 2.
I know, but it'll fall back to USB 2. I was wondering if that was in the application.
yeah, but if you go to this link, do we have a bomb?
It's the same thing.
Yeah, it's basically the same. Yeah. You will find the layers for Open Embedded to build the webOS plus ROS 2, and hopefully we can publish the bomb for this thing. We have it internally in our wiki, but I think you didn't publish it.
Yeah, I mean, you should check out the Open Embedded community.
I like that.
There is actually a special on Discord, the ROS Discord, there is a section for Open Embedded.
Yeah.
It's not very active, it's pretty dead, but it's
That's where I posted my failed 64.
Oh, okay.
Oh, really?
So I made a script to generate the install image with all the proprietary Wi-Fi components.
We should publish on Docker. I guess people would like to use it.
Yeah,
I published my Docker in
You have, okay.
32-bit ROS 2.
Yeah, it's cool.
Are you a grad student? What's your focus on?
Right now I'm working in security.
Security?
So,
we have an expert in security.
My background is in security.
so we had the ROS contact with ROS, SROS 2.
Yeah, yes.
And then yesterday, Monday, we had the workshop. Hands-on using ROS, SROS 2. So what we're trying to do is just improve the tooling. So that if you want to profile your system to auto-generate all the security artifacts. So like I worked on SROS 1, so I'm just applying all the lessons learned. One of the huge things is usability and security. If it's not useful, people won't adopt it. That's the point. So one of the nice things about that was like you could deploy your ROS application in audit mode and get all the annotated security logs, and then use that to auto-generate the minimal spanning security profile, and then embed that in the artifacts. And you could just switch to audit to enforce.
Yeah, it's like the hot hardware.
Yeah, exactly. That's where I took a lot of my inspiration from.
Right.
Do you have any suggestions? What's important for you for security?
Well, I don't work now on security anymore. Now I work on this thing. And I haven't looked what ROS does really. My background is more from cryptography and DRM systems. So I work with company who are developing white box application techniques.
Do you have any experience in trusted execution environment?
Yeah, that was one of our products, kind of for hardening system for verifying what you're executing.
Yeah, so one thing I think that would be really nice to have trusted execution support for SROS 2, or like at least more that's more like security DS, where
Like based on trust zone, right? No,
yeah. So where all your private all the secure transport could operate in like a co-processor, and that way you could
That
shield
was a thought from ARM.
Yeah, so we were talking about ARM and how to do that and how far they are along there. One thing I was interested in is their performance benchmarks, like what overheads you incur to do this memory transfer from a secure coprocessor.
If you prototype Raspberry Pi is great for that. Raspberry Pi has like a trusted execution support. It doesn't have encrypted memory, so it's not like a real production product. But if you want to experiment with trust zone execution, it has all the support for that. It has a system management mode, you can switch between them. You can separate OS, like if you run Opti there, it supports all
I
that.
didn't know that.
We are actually in LG doing that for supporting year end to do this thing for Widewine and Pirated. So Raspberry Pi works with that way.
The other thing I was interested in is more like at a station. So that's where like let's say you're in the autonomous vehicle and you have a bunch of sensors, maybe they're like processors, but you want to have the robot be able to like verify the integrity of the sensor that's using to make the decision process, right? So no one has changed the firmware in the LiDAR or the belt line to hallucinate saying, stop signs are gone.
Very ambitious.
So it'd be nice to have like an Intel SGX. They have an attestation service where you can, if you're talking with a remote party, you have some way of verifying the process memory and the remote enclave. Is
signature of the code actually.
That's intense.
It's and
That sounds so cumbersome.
it's very difficult.
I'm not quite sold on the current state of it yet, because you see how Intel right now is like leaking security.
SGX has been broken like 2-3 times already. Two, 3 different ways.
It's like, your secure keys sealing is no longer guaranteed. can act as like
it's not
memory
easy.
or co-processor.
I think the best option for these are like secure elements from NXP or similar semiconductors.
They dug their own grave with that.
It's unfortunately, yes. I work with NXP.
With that ring, let's see. What's the management unit?
I don't.
Why would you give your management unit like ability to do your network stuff?
It depends on which particular models are you talking about, but I think there's a solution, but like physically producing hardware which is separate and which is hardened hardware level, not on software level, like Intel SGX. It's much better approach. It's much more expensive, much more harder to integrate, much more difficult to convince people to put another chip on their devices. But I think that's the only way how to really guarantee this kind of stuff. I mean, NXP chips are out now, these real passports in NFC cards, and they kind of haven't had them being broken yet. So they kind of guarantee the security. Yeah, it's a big topic.
Thanks for
Thank you.
Yeah, thanks.
speaking to me. Very informative.
Yeah, if you will have any questions or problems, just let me know. I have sent you a LinkedIn request.
Yeah, when I get some free time, I'm gonna try and look at the emulator and I'm also building the OSE 2.
Are you located in California?
Yep, San Diego.
Do you think about moving to Bay Area?
We're hiring.
We're hiring.
No, you're all based in Silicon Valley.
Yeah,
Yeah, so I worked in Silicon Valley for 3 summers.
We can make it permanent.
Cost of living, man.
Well, interesting stuff is happening in.
Yeah, that's the hard thing. It's like there's so much cool stuff going on. It's so hard.